Okie doke, guys. In this lesson, we're going to learn how to solve equations and justify our steps into solving the equations. And we're going to be working with the properties of the real number system. These are the justifications we're going to use. When we solve an equation, we're going to use a process called deductive reasoning, where we apply ideas that we already know to be true. For example, we have this equation 8x minus 12 equals 28 right here. If we were to solve this, we would know that we would have to add 12 to the left and then also to the right to keep it balanced. So many of the ideas that we're going to use when solving equations are the mathematical properties or rules of the real number system. Here are a list of the most commonly used mathematical properties. And when we use the real number properties such as commutative, associative, and distributive, as well as the properties of equality, the properties of equality, guys, are just the things that if you add to the left, you have to add to the right. If you subtract on the left, you subtract on the right. So using the real number properties and the properties of equality is what justifies why each step in the process of solving a linear equation is legal, what makes us be able to do that. Now, let's take a look at 4 possible types of solutions. We're going to solve these to see what type of solution we get on the end. So here we're going to start with adding 6 to both sides, which would be applying the addition property of equality. And then we're going to apply the division property of equality. We're going to multiply both sides by 2. We're undoing the multiplication by dividing. And our solution is 20. This means we have exactly one solution. The only value that will work for this equation is 20. If I plug in 20, that means this statement will be true. We will have 4 equals 4. Now let's look at our next example. Let's distribute the 2. We have 2x minus 2 equals 2x minus 1. When we have variables on both sides, we typically remove the smallest one. But in this case, they are exactly the same. So we are going to be eliminating the variables altogether. And we're going to be left with a false statement with no variables. So when you have no variables left and a false statement, then you have no solution. That means there's no value in the world that can make this equation true. Now let's go on to our third. We're going to distribute 2. We have variables on the left and on the right. We're going to eliminate these because they are exactly the same. And this time we have no variables, but we have a true statement. We have negative 2 equals negative 2. This means I could put any value I wanted in for x here, and I would always get a true statement. So this is infinite solutions. Our third example, we're going to isolate x by adding 4 to both sides. We're going to use the division property of equality. And to undo something that's being squared, remember, you're going to take the square root. So when I take the square root, it undoes squaring. And if I take the square root on the left, I have to take the square root on the right. Now, here's something new. When you take the square root of a number, you need to include both the positive and negative root. So my x, my solution would be positive 6 or negative 6, because a positive times a positive would give us that 36, or the negative 6 times negative 6 would give us positive 36. So that's how there are 2 solutions. So you could say x equals positive 6 or negative 6, but I like to use this symbol here. Okay, let's get into a 2-column proof where we're going to use our justifications and we're just going to solve. So our very first statement is just the problem itself. So we're just going to write our problem. And this is always called the given because it's been given to us. Now, over here, I've provided a place if you want to show your work, you can do this. So here, the first thing we need to do is we need to combine like terms. So when I combine these, I get minus 12 equals 16. So we're just going to say combine like terms. And some people are more detailed in their 2-column proof than others. I'm just going to keep it basic. The next thing we're going to do is we're going to add 12 to both sides. So if I add 12 to the left and I add 12 to the right, that's going to be the addition property of equality. And we can just abbreviate here. The next thing we need to do is we need to multiply both sides by the reciprocal of 2/3. So I have 2/3 times x equals 28. And we're going to multiply by the reciprocal to make this a positive 1 coefficient. So x is going to equal, I'm going to do the simplification diagonally. So 2 goes into 2 once and 2 goes into 28 14 times. So we really just have 14 times 3. And that is 42. So we get x equals 42, and we use the multiplication property of equality. And we have exactly one solution. So I'm just going to say exactly one solution. Okay, look at example 2. We're going to write our statement on our first line, exactly the problem. This is called the given. Now, we need to first distribute, because if you have parentheses, that will be the first thing that we need to dissolve is the parentheses. So we're going to distribute the 3. So I'm just going to put the reason is the distributive property. Then we can combine like terms on the left. So 3x plus 5x is 8x. So we did combine like terms. Now we have variables on both sides. So we're going to subtract 8x on both sides, and that's going to eliminate our variables. So we use the subtraction property of equality, and we have no solution. There's no value to put in for x that would ever make the left side equal the right side. Okay, example number 3. Let's write our given. So we see we have parentheses on the left and the right, so we are going to use the distributive property. On the right side, we're going to have 9x plus 3. On the left side, I'm going to work this out. 3/4 times 12x. 4 can go into 12x 3x times, so that gives us 9x, plus we have 3/4 times 20. 4 divides into 25, so it's 3 times 5 is 15 minus 12. We can combine these like terms. So this is combine like terms. We have variables on both sides. They're going to be eliminated because they're the same, but we're going to be subtracting. So we're going to say the subtraction property of equality. And we have 3 equals 3. So we're going to have infinite solutions. You can also use the infinite symbol. So that means any number can be substituted in for x here, and the left side will always equal the right side. Okay, let's do a fourth one. So this has many steps as well. So this is our given. So let's talk about this problem. Always like from the perspective of x is going to be squared. So let's write that out. It's going to be squared, and then we're going to multiply by 2, and then we're going to add 6, and then we're going to divide by 3, and then lastly, we're going to subtract. So if we knew the value of x, that's what we would do with order of operations. We would square, multiply, add, divide, subtract. So to undo it, we're going to work backward. So from the x's perspective, the minus 12 was the last thing done, you can see here. So we're going to undo all of these working backward. So we're going to add 12, we're going to multiply by 3, we're going to subtract 6, we're going to divide by 2, and then we're going to take the square root. So we're going to add 12. So that's the addition property of equality. Okay, so we added, so we undid subtraction. Then we're going to get rid of dividing by multiplying. So we're going to use the multiplication property of equality. So we're going to multiply both sides times 3. And when I multiply by 3, if it was 25, that would be 75. With 3 more would be 78. Now we're going to subtract 6 from both sides. So the subtraction property of equality. And then we're going to divide, so the division property of equality. So when we divide by 2, we get x squared equals 36. Then we're going to take the square root, so the square root property of equality. And when we take the square root of both sides, remember you're going to get a positive and negative root. And the square root of 36 is 6. So we have 2 solutions. Awesome. So if you have a complex problem like this, you can map it out by saying, what would I do if I were doing order of operations? And then solving is the opposite and inverse of order of operations.